One method for multiplying polynomials, and specifically a binomial with a binomial, is called the FOIL method. The FOIL method could be expanded to larger polynomials like trinomials, but we wouldn't call it FOIL, it would just be the distributive property. FOIL is just an acronym for first, outside, inside, last. So if you're using the FOIL method, you're going to multiply the first term of one binomial with the first term of the other binomial. So in this case, x times x is x squared. The outer terms, in this case, x times 2 to give you 2x. The inside terms, 1 times x to give you x. And then the last terms of each binomial, 1 times 2 to give you 2. And then each of these terms, they've written them across the bottom here. If we have like terms, like we do with 2x plus x, we combine them to simplify our polynomial, in this case, 2x squared plus 3x plus 2. So if I want to use the FOIL method, and sometimes students will call this the rainbow method, because rather than writing it out in that vertical method like we had on the previous screen, students draw arcs. I have a tendency to draw 2 arcs above and 2 arcs below. So x times x is x squared. X times negative 7 is negative 7x. 3 times x is 3x, and 3 times negative 7 is negative 21. The key to using this method is that each term in the first polynomial gets multiplied with each term in the second polynomial. And again, we have like terms in the middle, so we're going to go ahead and combine those. X squared minus 4x minus 21, and we have the product of x plus 3 and x minus 7. Let's try this over here where we have leading coefficients that are something other than 1. It's the same process. 2x times 5x, 2x times negative 4, negative 1 times 5x, negative 1 times negative 4. So 2x times 5x, 2 times 5 is 10, and then we have x squared. 2x times negative 4 is negative 8x. Negative 1 times 5x is negative 5x. Negative 1 times negative 4 is positive 4. We have like terms in the middle, so we're going to go ahead and combine those. So we have 10x squared minus 13x plus 4. And we can use this method even when we have fractions. First terms multiplied, outside terms multiplied, inside terms multiplied, last terms multiplied. What you might want to do here, especially if doing fractions in your head, doing mental math is not the easiest thing to do, is when we get to the fraction parts, just go ahead and write what that looks like. So 2u times u, I'm going to go ahead and write as 2u squared. But for 2u times negative 3 halves, I'm going to write that as negative 3 halves times 2u, so that I have my fraction closer to my whole number, plus 1/2 times u minus 1/2 times negative, oops, I don't need a negative since I wrote the negative already. So minus 1/2 times 3 halves. This just helps me see what I'm multiplying with my fractions. When you have a fraction times a whole number, remember you can take the numerator times the whole number and divide by the denominator. But I also am kind of looking ahead here, and I see that I have a u and I have a u. So I know I'm going to have some like terms. So I think rather than divide by the 2 here, I'm going to keep it over 2 so that I can combine these two terms, because I also see that these both have a denominator of 2. So I'm just trying to simplify some of my work. So 2u squared minus 3 times 2 will become 6 over 2u plus 1 over 2u minus a fraction times a fraction means you multiply straight across, 3 over 4. And then we can combine these two terms in the middle for 2u squared. Negative 6 halves plus 1 half. We have a common denominator, so negative 6 plus 1 becomes a minus 5 over 2u minus 3 over 4. So even though we have fractions in our binomial, we can still use the FOIL or the distributive property to multiply.